Hello students. In this video we're going to show you how we actually interpret the gradient of a line in a real life situation. So when you find the gradient, you're measuring the steepness of the line. What does that actually mean in real life? So let's have a look at this example here. Sylvia is draining a bathtub of water. The graph shows the volume of water in liters in the bath after a number of minutes. So if we look at the graph here at 0 minutes, which means before she started to let the water out, the bath contained 320 liters. And it went out of the bath at a steady rate. And after 8 minutes, the volume is 0, which means basically the bath is emptied. So let's go ahead and see if we can answer some questions using that graph to assist us. Okay, so question A, how much water did the bath contain originally? Well, that's when the time is 0. The volume of water was 320, so 320 liters. How long did it take for the water to drain from the bath completely? Well, once the volume goes down to 0, that took us 8 minutes. Okay, what is the gradient of the graph? We can use rise over run to get from that point to that point. The rise is negative 320 because we're going down. The run is positive 8. Well, 8 goes into 32 4 times, so the gradient is negative 40 for this particular graph. Question D, at what rate was the water being drained away? And that means how many liters per minute, basically. Well, it turns out you have to do the same calculation for the rate. The rate was, it dropped by 320 liters in 8 minutes. So it was being drained away at 40 liters per minute. And these two questions here tell you what a gradient represents in a practical situation. It represents the rate at which the variable is changing. So a gradient is a rate, and a rate is represented by the gradient. And finally, what does the negative represent in your answer to part C? Well, the negative in this case means that the water is decreasing. So the volume is decreasing and not increasing. I think that might be the only page I'm doing on this video, but let me just have a quick look and see if there's a second question on this. And there's not. Okay, so we're going to stop there. So the point of this is to show you that the gradient does have a physical meaning in real life problems, which is it's basically the steepness, the gradient just represents the rate at which a variable is changing. In this case, it's how quickly the volume is changing per unit time.